let's go over some announcements having finished quiz number 2. How many people liked quiz 2? Just a couple people liked the quiz. Well, I always liked exams more than quizzes, but that's because where I went to school, my college, we had unlimited time for exams. What the faculty would do is they'd put all the tests over in a testing center. It was just like this building, and the only purpose of the building was to go take tests. And they'd say, take the exam Tuesday or Thursday. So you'd pick a time when it was good for you, and usually, if there was any time limit, it would be like 3 hours. So there was always plenty of exams. So you could just get in there, work, think about it, check your work again, eat some Skittles, play a video game, keep going. It was great. I'm sorry you don't have that same experience, but I'll try and make it fun. You bring Skittles if you like. Maybe that'd make your exam fun, right? All right, so the homework is due on Monday. I've got several people ask me this good question. What if the problem statement or my notes on the assignment sheet don't tell you whether to use a spreadsheet or the equation method or the factor method? So sometimes I tell you explicitly, use Excel for this one, or use the table method. If I don't tell you, then it's whatever you prefer. I see that a lot of you have your computers today, and that's good. We're going to continue to use computers on most days for the coming weeks. So I'd appreciate it if you can bring your computer in. I sent out an email basically explaining, number one, you don't have to have a fast computer to run Excel. Even my 10-year-old computer is doing just fine these days. Number two, you can get Windows for free from the university. So if you have a Mac, that's going to be really important to learn how to dual boot and run Windows software, because almost all of the engineering programs that you'll use for design are Windows-based and don't have a Mac version. And then number three, I also told you in that message that you can get Excel for free through the university. So there's that message. And then I also gave you a video. How many of you watched that video that I showed? I recorded a video yesterday, and it was basically showing how to dress up an Excel spreadsheet so that the grader can understand what you did, and so the grader can find your answer. Because the way it works through MU Online, the instructor view will load a preview of the file, and that's very quick. And it's easy to see the preview, but if you actually have to download and open the file, it takes about 10 times as long to look at the work. So for that reason and others, because in the future you're going to be communicating calculations and designs with other people, it's important to get in the habit of leaving little notes for yourself in the spreadsheet, like what was the input, what was the given, where is the output. Those little breadcrumbs of information will be critical if later on down the line you have to redo something that maybe it's been a few months or a few years. It'll be really valuable for you to get in the habit of leaving good annotation within your Excel file. So if you haven't watched that YouTube video yet, please do watch it before you submit the assignment that's due on Monday. I want you to get all the points you can, and the best way to do that is make it really clear to the grader what you've done and why. Okay, does that make sense to everybody? All right, so what we're going to do today is get a little bit deeper into complexity of cash flow diagrams and reinforce the lessons of Excel and how to use the FV function. But before we do that, I got a question today on the homework assignment about a problem where you're finding break-even point. Joe, do you remember what question number that was? Like the problem? Okay, well, it's problem number 4 on the handout. What I wanted to point out for you is that that problem is something that we've done an in-class exercise on. I think it was in class 9, so that would have been on Monday when we looked at the break-even point, where you're finding how many years does it take for a certain thing to happen. How many years till something's paid off. So that question, the 4th question on the handout I gave you, use this in-class exercise problem, in-class exercise 9 problem 2 as kind of the pattern for how to handle that problem. And it doesn't matter that in the problem you're working, these amounts aren't constant. You know, it's an annual series and a gradient on top of it, but Excel doesn't care one way or the other what number you put in here. It can do the calculations just as easy. So I wanted to point out that this is kind of like the in-class hint that I hope will help you solve that fourth problem. Okay? All right. So let's get into the stuff for today. I'm going to give you this in-class exercise cash flow diagram. On problem 1 of today's in-class exercise, this is the cash flow diagram, or one very similar to it. Not exactly this. But I wanted to show you how we could, using the factor method approach, find the present value of this. So what you can see is we've got an annual series as an inflow. And then what's going on down here, years 4 through 7? It's a gradient and an annual series, right? So there's a gradient on top of an annual series. So let me work you through the steps of what we have to do to get that to the present. I made a little animation last semester, and I'm so proud of it. So I hope you appreciate it. It took me like an hour to do this sequence that we're going to go through in about 60 seconds. So that's how committed I am to your education. The first thing that we need to do is we need to convert this annual series into a present value in year 8. So what we're going to do is find P given A at whatever interest rate we have, and N is 3. So when we use that, what we're doing is we're combining these 3 amounts into a single amount in year 8. So it becomes this big amount. We're converting it from the annual series to a single amount. Now we called it present, P, but year 8 isn't really the present. It's like a quasi-present. It's just from the perspective of this annual series, the present is the year before there was any amount. So this is the present, and as you might guess, we're then going to have to shift it over to year 0. So we took the annual series, we turned it into a single amount in year 8. All right? Next, we do find P given F. Now, in the last one, we called this amount in year 8 P, because that was from the perspective of the annual series. But now that we're trying to move it over to year 0, this single amount in year 8 is now a future value, because the perspective is shifted. Now our perspective is, what are we doing to get it to year 0? So we say, find P given F, and we're moving it 8 years at whatever interest rate is applicable. So it goes over to the present. Why did I make the arrow smaller? Because when we are moving backwards in time, that's discounting. So the number of dollars in the future is less when we're considering its present value. Good. So we've moved it to year 0. So that first annual series is gone. Okay. Next, this is going to be the complicated part because we've got 2 things there. We've got the annual series and the gradient. So the first thing is let's take the annual series that's there, let's take that to year 3. So it's 4 years worth, 1, 2, 3, 4. It's as though there are 4 years of an annual series, and we're moving it to year 3. So what went to year 3 is that which is inside the dashed lines. Okay? So it got converted over, and let's pretend it's not there anymore. There's just this amount. The second stage is we have to move the gradient to year 3. Now, when is the first year we see the gradient? Remember, 500 is the annual series, and so there's 0G, 1G, 2G, 3G. And so that's how a gradient works, is that the first time you see the extra amount is year 2 of a gradient. And so it will go back behind the year 2 from year 1 to 0. So both of those amounts will end up in year 3. And then our last thing is to take it from year 3 to the present. Now, the amounts that was in year 3 before, that was our present, and now it's considered the future. Because now we're considering our perspective is year 0, rather than the perspective being this gradient and the annual series. As far as the gradient is concerned, in the annual series, when we want to move it to the present, that's year 3. But if we wanted to get to the real present, which is year 0, then this is now the future. So those amounts will discount and we'll combine it together in whatever the combined present value is. Shouldn't have taken me an hour, right? Yeah. All right. Any questions about the process we've just gone through? All right, so you're going to do something similar. I've kind of flipped around where these things are. I'd like you to get some practice actually using the numbers. This can be highly collaborative. This one you're doing on paper. So problem 1 you do on paper. Then after we go over it together, then you can get started on, well, even if you finish early, feel free to start on problem 2 on the back side. You'll use the computer on that. If you sit on that side, you'd never have to be the last person who doesn't get the paper. Someone else would be shifted. Okay, so as I've been walking around, I saw some good stuff on the in-class exercise so far. Let me show you the solution so you can check to see if you're on the right track. All right, so what we've got is a multi-step problem. I started with the inflows. You don't have to. You could start with the outflows. It would be fine. You get an idea of what the steps are. And I try and label the arrows to make it obvious which amounts go with what arrow. You know, I think it's really important to put as much clarity into a solution as you can. And so where I've got some amount, I label the arrow that is equivalent to that amount so that you can kind of get a sense of where these arrows are coming from and what they mean. And remember, if you don't get a chance to write all this down, it's also going to be in the lecture video. So you can pause that video and copy down the solution if I happen to move through it too quickly just now. Let me try and expand out a little bit. I don't want to go too far because then I think the text is too small. Can you still see that on the back row? Or is it too small? I got a thumbs up. I'll take it. All right. So let me leave this on the screen for a few minutes and check your work. If you've got questions or you made a mistake that you don't understand after looking at this, let me know and I'll try and explain it a little better. All right. We only have 4 minutes remaining, so let me talk you through the structure of this. If you get hung up on a small mistake here or there, you can always correct that later, but what I want us to leave with is an understanding of the general structure and method of this assignment, this problem on the in-class exercise. Okay, so our first thing is we translate the cash flow diagram into a cash flow table. So we've got the years that the amount is in and the amount. Now, why did I suggest previously that you add a secondary time column for problems like this? Right, because the future value, it's not going backwards in time, it's going forwards in time. And so this amount in year 1, for example, it's in year 1, but it doesn't need to go n equals 1 years to get to the future. It needs to go 15 years to go to the future. So we add that secondary time column just so it's available, that number's available to use in the FV equation. Okay, so we put in the amounts. Now let me show you the FV equation. We'll step through what it's expecting to see in each step. The first field is for the rate. And why are these dollar signs in that reference to cell B1? What's the purpose of the dollar signs? What's that called? Anchoring or locking. So we always, regardless of what row we're in, we always want this function to be looking up here for the interest rate. It's not going to change as we drag the equation down. Okay, so that's the rate. NPER is the number of periods, and that's asking how many years into the future do we want to move the amount in question. So on row 0, the amount in question is negative $3,500, and we want to move it 16 years. So that's why we created that secondary time column. Okay, the double comma, because we have to skip over the payment field. We don't have 16 instances of $3,500. We just have a single amount of $3,500. So that $3,500 is in the present from the perspective of what we're trying to accomplish with this function. It's not a recurring payment, so we have to skip over the payment field. Last thing to point out is the minus sign. Why the minus sign? Oh, Excel isn't dumb. Excel is brilliant. We love Excel. But it just has a different point of view than we normally would have. And so we have to kind of cancel out its tendency to switch the sign on these built-in finance functions. Excel is a little dumb. Yeah. All right, so question A is, what is the value of the cash flow diagram in year 16? So if we move everything to year 16, the sum of the amount is $61,157. Question B, it asks, what interest rate would make that 100,000? So we play around with this interest rate till it's 100,000 by doing data, what-if analysis, goal-seek. Our objective is the sum should be 100,000 by changing the interest rate. So if the interest rate was 17.2%, then that amount, the total value of the project in year 16 is 100,000. Okay, well that's all we have for today. Time for today. It's 12:50, so I need to let you go. Just please remember on these announcements to, if you've missed a class, watch the video of the class you missed, and also take a look at that video on how to annotate Excel files. Have a nice weekend.